Today we're going to be working on unsupervised classification. And when we're done with this, we do go ahead with the supervised. But before we go ahead, in unsupervised classification, we're going to use the same data we use in supervised to do unsupervised classification. I'm going to use Landsat 8, and I'm going to use Landsat 8 that is covering Anambra State, part of Oka. And in Landsat, there are things I want you to know: the spectral dimension, there are different bands, and because of this I will go to say band combination of Landsat 8. So I like using this website, the GIS Geography. This is actually a very good site for me. I enjoy using it. So I will talk about the Landsat. There's a band combination for Landsat 8. So the Landsat 8 are the operational Landsat image, that is OLI, and thermal infrared sensor. This is trace. So it's actually produced 9 spectral band from 1 to 9, having 15 spatial resolutions, 30 and 60. So, and then the thermal resolution, that is the thermal infrared sensor, consists of 2 thermal band with spatial resolution of 100. So this is not where I'm interested in, or what I want to talk about is here. The RGB gives us the natural color. So it means that the arrow here is 4, the G here is 3, and the B here is 2. So RGB will give us a natural color, and both imagery are 30 meters interval. Now when we call image fusion, the image fusion is the process of using a multispectral and fuse it with a spectral, that is a panchromatic imagery, to improve the spatial resolution. So it simply means, for example, we have 30 here as spatial resolution. This is, I want to use this rate visible, and then look at 8 here, panchromatic. This is the smallest one here as compared to value, but have the highest spatial resolution, which is panchromatic. So in image fusion, in remote sensing, you use the multispectral to fuse it with the panchromatic to improve the spatial resolution. So what it means is that, for example, in mathematics, if you have 30 plus 15, that's about 30 plus 15 will give us 45. And if you divide 45 by 2, you are going to have 23.5 meters resolution. So what I'm trying to say is that you use this to improve this. So I am just giving an example randomly, because if you have 30 meters and you now fuse it with 15 meters, so it is going to make it better. Instead of the natural band color to be 30, it will be 23.5, making it better than what it is. So that is why I'm going to use this. Now I'm going to go down a bit. We already know this, but I'm going to go down a bit. So you need to note this. Assuming you're using Landsat 7, the band combination is RGB, so it is going to be 321. You are not going to make band combination of another thing. If you are using band 2, it is still RGB. So this is RG, but you have 3 and 4, which is Landsat 3 multispectral. So there are different band combination. Now what brought me here was to talk about this. Now it means that this is spectral band. So if you have band 32 and 432, you obtain the natural color of the imagery, because these are of different spectral bands. So it means that if you combine 3 to 1, you will get a natural color. So it is, if you are looking, this is applicable to giving you the natural color, and it replicates the close to what human eyes see. While the healthy vegetation is green, unhealthy flora is brown, and urban features appear to be white and gray dark. So this is how you can delineate these features. So if you are looking at color infrared, which is 5, 4 and 3, if you combine 5, 4 and 3, you get this type of band combination. what will you get? You see here that you have band combination, which is called near infrared. So it means that where you have vegetation, because of the near infrared and red color, it will reflect near infrared light, and this is usually used in analyzing vegetation. Assuming you are in the research of vegetation, then you can use this to see where you have red as beta 3 and where you have white or dark area as water body or urban area. So it is when you are working on short infrared, which short wave infrared, which you are want to check for where there is dense population or sparse population. So you can use this to check it. You can see here there is sparse vegetation. Here you can see it is lighter. Here there is dense vegetation. Now when you are working on agriculture, you can combine differently. Mostly when you are working on agriculture for crop monitoring, you use this kind of bands where you take the short wave and near infrared. The healthy vegetation appear to be darker, while the bare soil has a magenta color. So you can see here the healthy vegetation. This is a bit low healthy. This is a magenta, as you can see, which is bare soil. If you are working on geology, you can also combine the band of 762, so you will be able to watch, identify geological formation, the lithology, features, and fault. Then if you are working on bathymetry, then you need to make a band combination of 3, 4, 3, 1, which you are going to watch. That is when you're monitoring as related to coastal bathymetry and the aerosol studies. So because blue reflect the blue, it reflects blue, and so as you can see here, this shows you where the water is. So what am I saying this? Then we talk about the panchromatic, which I talk about. Then this is particularly used for pan shaping imagery with the panchromatic band, so you can shapen the imagery to produce a crisper product. So the vegetation index is where we also use the band. Assuming I want to monitor the vegetation index, which range from -1 to 1, I can use the band of near infrared, that is the red, and then the near infrared and red, which we use to monitor, do the calculation of NDVI. So in general, what I want to bring us here is I want to do a land use land cover classification. So the best way I can use is to use the 432, and the 432 show me what I can see naturally with my eyes, and I am going to use that to make a classification. So that is the reason why I came here, and that's why I said you can make a band composite to all of them, but select the band you want to use. So for the sake of what we are doing today, I will return back here, and like I said, I open up here. How do you know which one have this bound? This is the satellite image I'm going to use, which is land sat 8 is exactly what I'm going to use. So I'm going to use Landsat 8. The date is on 22/1/20. That is, this image was captured on 20th January 2022. So this is the properties of the Landsat, where if you open up this, you should be able to see the Landsat scene. This is what it means as related to the scene here. Then this is the spacecraft ID Landsat 8, that's the mission. How many spectral band? 11. How do you know the band here? If you look here at the end of every of this imagery, you see B1 band 1, B2 band 2, B3 band 3, B4 band 4, this is band 5, band 6, band 7, band 8, band 9, and band 10, band 11, dot TIFF. All these ones are other files, as you can see. You see, it stops at B11.TIFF. It started from here. Now, if you look at this, the only one that have a higher spectral resolution is band 8, the panchromatic. So, because it has 50 meters resolution. So this one, you get to know, this is like a metadata, where you get the group projection, ellipsoid map projection is in UTM, is in meters. That means it's for ellipsoid, and it is located in zone 32. Then the projection parameters, the ephemeris epoch 2022, the day is like I said, this 20th. This was captured in January. You can see the time, the number of point control point it has, and you can get all of them here. It have about 50 or 55, sorry, and you can see where everything about it. So you see this is the metadata, and if somebody asks what is the metadata, this is what you can show the person. Everything that's related to the data are contained in this file here, the cloud cover, whatever you need to know. So you go through each of these documents to be able to understand what each of them means. So you can also see it here. So it is a long paper. So you can see here the band 1, the cloud cover here. As you see here, you see cloud cover is 0.63. This is very good, means there's no cloud cover. Just like when we're talking about how are you going to download the imagery, and I was saying that you need to reduce the cloud cover so that you should be able to see filter the one that have a lower cloud cover. So the panchromatic, like I said, is 30. The cell reflective is 30. The panchromatic, sorry, is 15, and is located in UTM zone 32. Now, sometimes somebody will tell you to go and download the image, and the person asks you which part and row is it located. To know it by the name of the Landsat, you will know, because you see here, I have Landsat 8 L1, which is level 1, top, that is TP, and then it is in row and part of 188 and 55. This is the date where it was downloaded. So this is a way you can know. So what I'm saying this is that as a GIS expert or remote sensing specialist, you need to understand the data you are downloading. Why are you using that data? What is the meaning of that data? And it is this combination here that shows you the forms. That's why if you go to Landsat, by looking at this, I will automatically know, oh, you are using Landsat 8 or Landsat 7. Why? Because I look at the identifier number, as you can see, and I should be able to tell you, oh, this is what it means. So, and all the file are in GeoTIFF. So it is the combination of these things that was going to give you a real life imagery. So with this, I'm going returning back to ArcGIS. Now here, if you go here and you add all these data here. So let me give you an example. If add band 1, this is band 1, this to band 6 here. Then if you move it a bit here, you will see get other band. So like you can see here, band 7, band 8, band 9 here, and you can see band 10 and band 11 at the other end here, which is TIFF. Anyone that have TIFF BT. So here I stop at band 9. You can see it here. This is none of these have BT. So if I add all of them, so what you are going to get is something that looks like this. There's going to be a black colors. It doesn't make any meaning because they are sensed in different band. So you can see, and I can interact with each of them. If I turn off this, you see what it shows me. So if, like what I'm trying to say about band 8, if I zoom close to a particular place, as you see up here, you can see here, this is what you're going to have. If I keep on zooming a bit, is exactly what I'm going to have here. So if I turn off each of the layer to interact with it, you can see what you have is something looking like this. This is band 10. If I turn it off, you have this. This is band 11. You can turn it off. You have this. This is band 2. You can see what I have as band 2. So this is a way I am making an interaction with them. But now for me, I don't need to start wasting time. Go ahead. I saw somebody raise hand. All right. So since nobody raised hand, so I can proceed. Okay, so I'm going to proceed. Now, like I'm saying, this is a different way to see. So you are only going to have something that looks like this. So here, you will not know what is probably here until you are done. So I'm going to zoom to layer. Then when I zoom to layer, you can see the whole imagery in the tile. Now in this way, what I'm going to do is I'm going to do what we call band composite. Now in band composite, it is under Arc toolbox. You can click here and it comes out, or you can go here and it comes out. So band composite is a process of bringing these different bands, like it is bands composite. So you bring them to form one single data set. So to form one single satellite imagery, because they are of different layers. So you bring them. So to go to get band composite as it is, you go down to here. You have data management tools here, and then you go down to raster here. We have raster here. You now go to that raster processing. You click on the plus and you can see composite band. And when you click on it, like I said, what is band composite? It's, oh sorry, I click on pan shape on the wrong one, so I'm going back to click on band composite here. Then you can see it says create a single raster dataset from a multiple bands. So now, what do I say about the band combination that made me go there? I want to combine different bands for it to form something to reality. So now, I am looking for band 4, because if you look at what we talk here, we say that the combination of band 4 to give us the real life imagery, which is natural color, we need to combine the band of 4, 3, 2 in that order. So I am just going to make a combination that way. So I am going to select band 4. How do I know it's band 4? Because of this thing, the place the mouse is rotating. So you see now that that is band 4, B4. The next thing I need to do again is I need B3. Then the next thing I need again is I need B2. Now to improve the imagery, I'm going to add the band 8, which is the panchromatic. Now look at the arrangement. If I want to arrange this one at first, I will make it like this. You see now 8 comes down here. If I want to make it up, I will still make it that way. Now it is now in 4, 3, 2, 1. So it means I'm going to have band 1, band 2, band 3, and band 4. Once I am done, I can click OK. So I want to put it in default geodatabase. So later I can extract. So I don't want to define the location is going to be, and that is why I didn't select the output location. So I just want to make a band composite using just 432 because I am only interested in natural color. I can make band composite all of them, and then I will select the one I want by those band combination, so that I should be able to know this one is this and that one is this. So to make that, maybe when I am done, this is done, I should be able to make those band combination so that I can iterate or I can show you this as it is here. The changes when you make band 1, what is it band 2, what it is, and you should be able to form a single image where you can a band composer. But I didn't want it to like waste our time trying to make that. Like I said, you can make a combination of all of them at the same time. So once you make it, you should be able to select the visualization of a particular one you want to start. So that is exactly what I had. That's exactly what I am doing, and that's exactly why I decided to only use the one I want, which is 432, which is RGB in that order. So I didn't want it to waste our time, so that's exactly why I decided to pick those bands. So now what I did was just that way. I bring it up here to try to make a band component where I can get the particular bands I want, which is the natural color. Yeah, so while we're waiting for it, I'll be talking about this. So you see here, like I said, today we are going to be talking about unsupervised classification. And when you look here, you see we have maximum likelihood classification. We have ISO cluster, which is unsupervised classification. We have class probability, and we have principal component. Now, this, as you can see, you can also get the same thing here by going down to raster here. You go down here, you go down to the spatial, that is here we have, you go down here, like go to Arc Toolbox, then you go to spatial analyst tools, you go to multivariate here. All these are here. If it is not here for you, you can right click here and go to classification. So when you go to image classification, check it here, you should be able to see this here. But if you can't see it here, and if you don't want to keep it there, you can always get the same thing I'm going to use down here. Now in this case, I made a band composite using what I showed us here, which is 432. I should be able to have a natural color. So you can see this is my natural color imagery, where I can see the image in natural way and able to see the image in natural sense. So you can see here, this is the part of like a water body, and then let me pan around. You can see here where we have residential area and rest of them. So in this case, I don't need this one to here, so I can decide to remove them for now. So I'm just going to remove it. Then you see that I'm only left with the RGB images. So if I change this thing to band 1, you see the color will change. This is what I was talking about, because if I make band composite in all of them, if I change the color, the arrangement, the color of the imagery is going to change. So that is why it is RGB. So RGB will give you the natural color. Now in that case, you can see here we have formed a natural color on this imagery. Now what next am I supposed to do? Because I'm going to do ISO cluster, because I'm going to do unsupervised classification. So in this way, there is something again I will do to get this fast. I'm going to get the satellite imagery, the shape files, to narrow down to where I want to get. So I might just decide to go back and say, let me choose Orca South or Orca North. So I'm just going to go here and then get the Nigerian shapefile and download Nigerian local government here, add Nigerian local government as a overlay on it, and able to get the place I want. So if you have a question, you can go ahead and ask. All right, so now,
Hello, can you hear me?
yeah, go ahead.
Can you hear me?
Yeah.
Sorry. My mic was having I was having issues with my mic. The first question I have,
Mm,
you said something about joining 30-meter resolution to 15 meters. It will
yes.
give you 45. Does that mean the resolution will be better? I thought the lower it is, the better the resolution.
Yeah, I didn't say
Then I have
45.
an other
I say if, for
okay.
example, that you have 30 and 15. So if you add all of them, what will it give you? It will give you 45. If you divide it by 2, it becomes 23, improving the spatial resolution of a multispectral. That's what I said. It will be 23.5 or 22.5, sorry. So making the
Okay.
spatial resolution of the one that is multispectral, which was 30, to be better. Is that okay?
Okay. Yes, it's
Yes.
okay. Then my second question is this:
Okay.
how you are interpreting the label? Because in my own, I'm trying to add it to ArcMap. I'm seeing after I've successfully seen band 1 to 9, I'm seeing MT something else, QA something else. I can't find like I can't
The,
find the remaining band. I'm seeing other things,
the
but they
way
look like
the way I interpret it is, I told you that look at this as it is. You see that after the T1, which is the category it belongs to, the T here means category. The T means category. Then the 2 here means the level. This is the date and this is the pattern row. The B here means B1, this is B2, this is B3 band 3, this is B4 band 4, this is B5 band 5, down to B11. Now, if you download an imagery that is not in this level, you might not be seeing band 8. That was why when I was looking for the imagery, I made an explanation. That's the reason why I always open to check. So it depends on the mission, the one that doesn't, if it doesn't, if the sensor or the this thing was not equipped on the Landsat image, you won't be able to see the band you want. So the way I interpret is that the B1 means band 1, B2 means band 2, B3 means band 3. Now I went here to show us that the band combination of Landsat 8 see the natural color, you have 432, and that is why I decided to make 432 and then add band 8, which is in 15 meters, to improve the spatial resolution. That is just what I did.
Okay, thank you. So in any situation I want to see color, I have to use 432.
Depending on the satellite, like I said here, I made example of the satellite here. When you're using OTL, that is band 8 and band 9, it is 432. RGB is R, this is visible red. GB is a natural color, like physics. Now if you're using Landsat 7 thematic, this is R here, GB, which is 321. Then if you are using Landsat 4 and 5, it become RGB still 321. But if you are using Landsat 1, which is around, Landsat 1 was launched into, and that's the first set of this, which is 1975 or so. So you can check this and you see the RGB, it is red and green. That was when the equipment was not, so you can see the different band that is up added here. So the band combination is here, where I say that 432 will give you natural color, infrared depending on what you want to analyze. If you make this kind of combination, it will give you this. So for me, I decided to pick the band I need. I can stack all of them once and arrange it 1 2 3 4 to 11. So if I want to see RGB, I'll just select R4, G3, and B2. You get a point now?
Yes, I get the point. Thank you. But please, the material you found those of, is it online? You just went to search for it.
Which material?
That place you are reading out natural color and the color.
Yeah, I just went online. I showed like I like using that. It is online, so I just go there to get
What will
them.
I search?
Just
Bam.
go to GIS. I'll share this. I will attach it. I'll share it with you,
Okay.
and I'll also attach it with a video. So just go to GIS. So you can search. Just go to, even if you don't, it's not this one. Just type band combination of Landsat 8 or Landsat 7, depending on the Landsat you're interested in. Is that okay?
Okay. Okay. Thank you.
All right. So I'll go ahead. You can see different local government here. As you can see, I just want to, maybe I want to work on different local government. I can decide to clip it based on the different local government. So in this case, I'm just going to randomly select something and clip it with whatever it is. So I will select from here to here to here to make this kind of clipping here, here, and I think this is okay. So I want to work on this local government I selected here. So in this case, I'm going to right click on it, and I am going to click data, export, click on it, and I don't even have location where I want to save it, but let me come here and then copy this up here and go to where I save as sterling. So I'm just looking for where to save it up here. So I'm going down here, go to geomatics, go to my name, and then I'll save it in sterling folder. So let me save it in sterling folder, and I'm going to save it satellite data. So I can, let me just put up here new folder, and let me just type this as ArcMap, and then I'm going to copy the directory here. I'll return back to ArcGIS and then paste the directory that I copy here, press enter, and then it is inside there. Then I will change this here to shapefile, and then I'll write the name here as area of interest, click OK, and then I can click OK and export, and I will say yes, and that's done. Then I can remove the Nigeria shapefile. So you see, this is the area I want to work on to reduce the time that my data is going to take me to load up. So I probably want to clip it. To clip it, you don't clip using geoprocessing because it is raster. So in this case, if you go to clip, this is not going to work because it ought to be a vector. So there are two ways it's going to work. The first way is go to raster here, go to raster processing, and then go to clip. This is the first way, which I just believe that's going to work. Input raster is this. The output extent is area of interest. Now when I scroll down a bit, I am going to say here, use the input feature to clip here because I want it to clip it at the area. Then here, maintain external, I check it. Here, what it means is sometimes when there is a data that no data, if you want it not to export it, use 0 there. Then here, I'm going to reduce this to L8. So I'm going to reduce the size because it might fail. So I'm going to make it 20. I'm going to put it 2022. So I'm going to make it 2022, and then I'm going to click OK. So I am clipping the raster. This is the first way you can make the clipping. The second way you can make the clipping is to go to spatial analysis tools and then go to extraction and then say extract by mask. So these are two ways you can clip a raster imagery. So that was exactly what I did. Or when you are doing an export, you can say a raster extent, you go to the environment and set the output extent and then select the shape file that you want to use, and that is the second method you can use. So on this case, if you turn off this, you can see that it have extracted to the place of interest. So I can turn off this build layer and I have this remaining. Wow, this logo look nice. So this is the first method, and then the second method, like I said, is go to spatial analysis tools here, then go to extraction, and then come here to extract by mask, and then select the imagery the way it is, and it's going to make those extraction. So this looks like a bird and I like the shape. All right, so you can see here we have extracted this. Now the next thing I'm going to do is I want to do unsupervised classification. Now in that supervised classification, there is something I want to do up here. For this sake, I might not need this imagery, but let me still keep it here and still use this. Yeah, go ahead.
I'm so sorry, but please, I want to just catch up. That's what I'm asking. I missed where you were stacking the images together to make it colored.
Did you come late?
No, like I was there, but I don't know where you pressed to bring out those multiple box that you stacked 432.
Yeah, to get that, go to, I'm going to close this again. I'm going to return the way it is. Then I'm going to go here. I'm returning back to data management tools here. I click on the plus sign. Then I'm going down to raster here. Then I scroll again. I'm go under raster. I'm going to raster processing. You will see composite composite bound. You click on it, it's going to open. Any imagery, those things you see, you can select 4, 3, 2, 1, and you can rearrange them with this. Is that okay?
Yes, it's okay. Thank you.
Thank you, mom. All right, so back to what I'm saying, I'm going to click on this to actually cancel it. Now, this is the imagery we want to work on. Now, I will take a close inspect by looking through, panning through it. And I realize that, oh, there is bare soil, there is urban that's green, there is residential area. Now, in my own look, this place looks like agricultural area, so I can zoom to make a close inspection on the imagery I want to work on. So if you look at this, you see that I have this place as urban area, I have this place as, like, you can see urban area here. So we can just pan around to make like a kind of observation. You can see here water looks like a water body. This place looks like a bare soil, that's a cultivated area, looks like a farm. Now, if you keep on panning, you see that this place looks like urban area. Like I said, I've explained that in the beginning about the imagery. Look at urban area. You can see here, there is a water body here. So we're going to do unsupervised classification. Now, the unsupervised classification, you give it the number of bands, however, how many ways you want it to be, and then it's going to decide using the inbuilt algorithm to check, oh, this place is looking like here. Let me classify them according to the cluster. We have talked about the pattern. We didn't talk about it, but we learned it in school about photogrammetry using hue, cluster, pattern, and then color in photogrammetry imagery. So we have talked about it in school. Now I'm here. Here that we are talking about, I am interested in this image. Remember classification, any imagery that is selected here is the one you're focusing on. So I'm going to change it to what I'm interested in, this man. Now, the next thing I need to do is I'm going to use the principal component. Now, the principal component set the raster and generate a single multi raster as an output. What is the importance of principal component? It help us make the image coherent. So some people don't use it, but me, I like using it. And because I like using it, I will use it. So in it, I just selected imagery I'm interested in, and then I want to run the principal component. This will help me purify, reduce the noise on the imagery, making the imagery better. So I have selected that and I've run it. So the principal component is here. Principal component, perform principal component analysis on the input imagery. So with this, I want to improve the quality as related to removing the sparklers and noise. So I want to make the imagery better than what it was, so that since I'm doing unclassified unsupervised classification, I should be able to have a better output to what I'm going to. So it will help me make this image removing the noise. So I like using it. So you can read more about principal components on ArcGIS. So you can also like study more about it. But I use it when I am doing this because I want to make this here. I'm feeling like it is a noise. I want it to make it better for me. Here, improve it. It looks like a noise. Here, do the same thing. Here, do the same, so that I should know in which of these places looks have the kind of same type of clustering. So as you can see here, this place looks like, so you should be able to group this thing into input levels where it will be okay for me. So that's exactly what I am doing, and that's why I'm using the principal component. So you can also use the same thing. Some people jump it over. I personally use it. So while we're working on that, so let me also save this. So to save it faster, I will go down to here and then copy the location and return back here and paste it, and then I will write it land cover land use classification 2022. So let me save the imagery there. So I've saved it up there. So that is why I'm using principal component. Like I said, if it is not here, come to arc toolbox here, still go here, go to spatial analysis tools here, and go to multivariate here, and then open it up. You can see exactly things I have. Even it has more where you can do edit signature, isocluster, denogram, create signature, class probability, and band collection statistic. So that is exactly what where you get it. You can, it's as it is here. Like I said earlier, if you want to bring out this, right click here, anywhere here, and then you go to image classification, check it, and that is going to bring it out here for you. So today we're only going to use ISO. Then next time we talk about maximum likelihood classification, which is supervised classification, where you train the imagery and it should be able to give you the output you are looking at. Okay, so while we're waiting for the principal component, do you have any question?
Please, while we are waiting for the principal component, I want to know what to do next. My own is looking as if it's too cloudy. It's now in the same color. Please, what should I do next?
Well, I didn't get your question.
Like I've been able to join it together, and it's looking too cloudy or too much cloud on it. It's not as clear as your own.
Yeah, because that was why you need to know what you are collecting. So that's why I was talking about the cloud cover. You know the cloud cover you're looking, so it must not look as clear as my own. We are not done. We didn't download the same location, and we didn't check this work on the same. Like I said here, if you look at the imagery here, look at my own metadata, you will see that my cloud cover is about 0.6, almost no cloud cover. Among if the cloud cover on my image is about 0.6, so that means you can see doesn't have. So when you're downloading, that was why I was explaining the part I say when you're downloading the cloud cover. When you're downloading, make sure that the cloud cover is reduced to a certain level so that you should be able to see road. So if you look at my own, you see my cloud cover is here, as you can see, is 0.63. So 0.63%. So it have grouped it into what I want. So as you can see now, it have improved it and it have given me the color I want. So by putting these things, you can see where you have this type of color means they are having this. So you can see these different colors, and here residential, here residential. So you should be able to put it for me in this pattern as it is. Is that okay? So if your own is not showing well, just know the reason, what caused it, and you should know what caused it is you didn't download the imagery that have a lower cloud cover. So that's why. So when I am done, I've created this, and you can see here. So the next thing I want to look is, for me, I have residential. As you see, I have a small bit of water body, then I have a bit of vegetation here, and I have a bare soil or agricultural area. So I have like in mind, I want it to give me water body, urban area. Then I have, there's no forest here, and I want, this is like a vegetated area, and I want residential. So I am having about one color, two classes, which is residential one, vegetation two, bare soil three, water body four. Then that is primarily four things I have in mind here. So because of that, I am going to go to class. Remember, the data you want to use have to be, so I'm going to use the principal point as what I'm interested in. So I'm going to ISO cluster here, unsupervised classification, click on it, and it will ask me which imagery. I've selected it and it's already in here. Now it is number of class I want it for. Then when I am done, this is maximum size, minimum size, output of the signature. If you need the signature to be outputted for you, you can click here, a signature file. I'm going to click on home, and I'm going to say signature of 2022. Then I'll save it up here, and once I save it up here, then I'm going to click on run. So it's going to classify it because it is unsupervised classification. So it's going to check using the algorithm to break this thing into 1, into 2, into 3, into 4. So this is 1 into 2 into 3 and into 4. That is what I feel like. We can make it 5, where we have shrubs, have water body, and we have vegetation. So but what I entered is the number of classification is 4. So I wanted to create it. I have interest in maybe urban area, water body 2, vegetated area 3, and this other one 4. So with this, it will be able to what happened. So it's only giving me one color. So let's open up and check the classification. So it only give us one. All right, so I think the imagery, let's try again. So I'm going to so, and then let me use this and then remove the principal with the imagery. So let's make it 5 and let us run it again. Oh, the name is too long. All right, so as you can see, it have grouped it into 5 for us. So now if you look here, I have iso cluster 1 2 3 4 5. Now what will I quickly do? I can go here, go to open attribute, and then go in here. When I go into it, this is the number of count, and I will add feed, and the feed I want to put is I want to put them in classes. Then I'll put it in test, and then I'll click OK. And then while I do that, I'll reduce it like this, and then take this by one side of it so that it can show me road. Now the next thing is under here, I want to use a swap tools, so I'm going to make a swapping. I'm going to select here, as I want the topmost imagery that I'm interested in is to be this one. So I'm going to put it here where we have principal class, and I'm going to click on this, and I should be able to swap across it to see what is in between them. So here, you see here, then this is swiping. Now when I put it up there, if I swap like this, I should be able to see what is under it, because I want to name the classification. Now from all indication, I'll click on this first row. You see it will select the place we have residential area. So for me, I'll click on this and start editing. So on editing here, I'm going to click continue, and I'll click on this, and I'll put it build up area. Now the next place is I'll still click on this to swap across. Now you see here, let me first and foremost and do play. So you see another place I am interested in is what type of thing am I seeing here that I have another color that looks like this color. So if I swap across it like this, and then the blue one looks like bare soil, the white one, which is probably, let me change this to a color of yellow so that it will be easy for me to notice it. Then if you see here, the places we have yellow look more of, can you people help us? So the places we have yellow look more of cultivated areas. So let's put it like the yellow, which is number 4, as farmland. And then we go back again, the places we have the color of the land looks like a water body, which is number 1 here. Number 1 look more of water body, so let me put it as water. Then the where we have blue, let's zoom close to it. So you see where we have blue, let me swap across it. It is the blue that look like water body, whereas where we have looks like a bare soil. So let me quickly check. So I'm going to zoom out a bit. Now I am making this by my personal judgment. The places we have one here is like a water body, yes. Now the places we have blue looks like a wetland. So let me make it a wetland. And then the last place here where we have blue, a green part where we have green. Go ahead.
Good evening. Yeah, I think, is there any other way we can as well be sure of what it is outside sweeping it like this? Because
Is by looking at the imagery, or if you're not looking at the imagery, if it is recently, you can also overlay it on Google Earth to see what we have there.
yeah, okay,
That will be
thank you. Yeah,
alright. So I'm going to make this vegetation because I didn't train it. So farmland, wetland, waterway, so you can make this up like this. So by the time when you're done, you can say stop editing and you say yes. Now once you do this, now if you go to the properties here and then go to its properties, go to symbology, change it from value to class. Because you want to label it, maybe also change the color you have here or make it a color of your choice, and then you can click on this and it should be able to give you the color you want here, labeling it under class. So with this, the places you have water body, which is wrong, then the places we have wetland, red, then the places you have this is vegetation, built of a turn to blue. So let's go back and supervise what we have here. So I'm going close to that particular place to see what we have here. Well, this red one, okay, let me check something. Alright, so let me swap across it again. The blue is okay, the farmland is okay. That looks like a bare soil, not a water body, because the water body is more of, yeah, that looks like a bare soil anyway, but that's fine. So yeah, this is a wetland. So the wetland, let's swap again. Yeah, that looks like a wetland. The other one looks like water body, but the water body is much, that's not what it's supposed to be. So we are going to make the classification into, yeah, that is water, but let's make that a wetland, and the one that looks like a wetland become still a farmland. So this is just like, this is unsupervised. You will just input in different, we say classified into four. At the same time, you can also merge this value, like where we have predominantly, for example, I am trying to say is the wetland farmland, because if you check this and turn it off to, like as you can see here, I am having this, and then if I swap across where I have the wetland here, you see that here that I have this color of wetland is actually looking like a farmland. So what I could do, or as well, is I can go to edit here and say start editing, and okay, and where I have farmland here, I can copy it and then go to where I have wetland and then replace it, so that when I stop editing, then both of them can be classified into one category. So you have two farmland, so we have reduced our listing into four sizes. So I'm going here to remove the value and then return back here to load the class, so that it will only be restricted to four different layers. So if I right click and zoom to layer, I should be able to have this where we have built up area in red, farmland in the other color, vegetation in this other color, and water body in blue, or whatever color that you want to make it. So this is for unsupervised. I didn't train it, I just work on it up like that. So in that case, this is the value it contains. So this is different value. This is farmland as it is. So once this is done, you can switch back to your layer here and then go to the print and setup, then change it to landscape as we always do, and then because of the size it is more of better in landscape. Then drag it like this, go here, you can make the same thing and the same way we used to design our layer. So I'm going to put it up here, and for easy distance, so I'm going to drag it here, and remember to make our distance the way we used to make it. So I'm going to right click and zoom to layer. So this is it. I can click on insert and then the legend, and I will remove this because I don't need it. Then I can quickly click on preview to finish it up, and that takes us here, and you see we have our built up area where we have farmland, where we have vegetation, and where we have water body. So you can also go here to change it to what it is. For example, if a built up area is red, is okay. If the farmland you want to change the color, you can also change the color of the farmland to another thing you want. Probably right click and go here to make the farmland look like this. The vegetation, you can make it look like vegetation. Then the water body, you can make the water body look like what it is. Now on this, when you are done, you can see these have been grouped into the way it is, or nevertheless you can also make them by color, like you see here. If I select this color the way it is, like looply, if I select this, it will group it into this way, then select this, it will group it into this way, depending on what it is. But every this have a conventional color, so which you can also adapt to. But by selecting this, you see it change into this way. So you can also make your own like this. So I can say flip colors, so that this is going to go up like this. So if I click OK, you should be able to group it like this for me. Then I can add the legend, remove it the way we used to work on it, and that will be fine. Now you go here, and I'm going to go to the attribute information, and then I can see under here, you see here that is not selected, so you won't be able to select this. So if I go in here and then make a selection here, and all of them are selected. So if you go here, you see copy selected, which I have selected. I can go to Excel, for example, and then click on this, and I can comfortably paste what I selected here. And you see here, this is number of count and this. So if, for example, let me right click and say insert, sorry, right click here, say insert. Now I have this here. So if I want to calculate the percentage of covered by farmland, like we do this and press Ctrl Q and then go to total, return back to this, click on percentage, and you can see this is the total percentage of this, which if you now sum it up to 100, you see you get 100%. So it means that this is the total area covered by land, covered by water, sorry, farmland, vegetation, um, and built up area. So you'll be able to see the um different percentage they have. So this as well, you can always use this to do display whatever you want to display depending on the way you want to make it. If you want to come like this or you want it to be like this, so you can make a kind of plot that you want to make on it and label it the way you want to label it. So this is a way, or you bring all of them into table and use the Python script like we did last time to write a code that is going to get this done. So remember that when you do this, you also need to do for 2000, and this is 222. If you want to make comparison between 222 and 224, you also need to do 224. When you do that, you should be able to see the changes that take place over over a period of time. Like I said earlier, that the unsupervised classification is always based on the algorithm. If the image is not clear, you will have other ones, just like Nulu is saying that her own have a cloud cover. So, but when it is not supervised, unsupervised, we can train the imagery, saying to the image, this is what we want and this is how we want it. So we're able to tell this place is vegetation, this place is bare soil, this is agricultural land, this is built up area, this is water body. So we're able to train the data to understand each of them. You get that now. So when you do this, you should be able to put up this and able to make a little bit analysis on the changes that happen on this over a period of time. Is that okay?
Yeah.
Yeah, so while Collins ask, so there are certain things you can do to get those things done. Is that if you look here, Collins, let me zoom a bit. The best way to get this done is, since I grouped it into four, so I am going to like carry this up here, and I am going to do a plus sign to zoom very close. Look here. If you look here, you see that here you have a bare soil, built up area, water body. If I turn this on, you see that what I classify is not majorly what it ought to be, because it's on its own. It's let me switch down to data layer. On its own, it is giving you a false listing, because what you're seeing is not what probably what you're seeing. Let me give you an example. If you look here, you see that I'm going to swipe across. If you look here, you see this is a residential area, no doubt about that. But this particular place is not a residential area, it's erosion cost area. You can see part of the water bodies. So what, for you to see this like the way you're classifying it, what you need to do is, like, I zoom very close and able to see, look at this now. This looks like part of water body, like softened, which is farmland. So, but you see, I classify it as water. Look at here, we have erosion area. Then you see now I am making it like a built up area, but you can see here it's not a built up area. And that is why, if you remember, we always, when we finish, we always do something like what we call confusion, like the matrices. So the reason is that when you do that, you try to check what is the correlation, what is the regression. So you should be able to now define, oh, this is going like this, or this is also going like this. So which definitely we are going to do as we go on. But, what I'm saying is, at the end of the day, you should be able to like understand what is it correlating, is it not correlating. So you should be able to make a kind of analysis between them to say, oh, this is like this or this is not like this. You get what I'm trying to say?
Yeah.
Yeah, so you should be able to make those claim and able to say, oh, this is going up like this or this is not going like this. So that you'll be able to make those claim why it is like that. Then now you remember when I was doing that here, let me give example again. Let me quickly run something. Now when I was doing ISO cluster here classification, and I say here classification, and I say ISO cluster, which is unsupervised classification, there is something I didn't tell us. I'm going to talk about it now, which is here, and I'm going to remove this. Now, if I say classify this into five, like I said, put five here, and then let me remove this. Maybe let me make this remove this is too long, and then leave this up here. Then where I say maximum 20, now you say output a signature file. Now you remember we outputted a signature file in a particular location we call ArcMap. This is the signature file here, and let me open it with Notepad. Now you can see information about it. This is the covariance. Now this is the means. Why did he classify it that way? So this is band 1, band type of class 2, band 4. This is the different layers, class ID, number of cells. This is the class name, the layer 1, layer 2, layer 3, layer 4. This is the mean. Now this is the covariance for each of them. Now this is the sampling. These are just the details about it. And now when we'll be working on supervised classification, I'm going to be talking to us about this, which we are going to be talking about the maximum likelihood classification, because you are going to train in data. And if you look at this, you see that here we in the other one we have what we call confidence raster, which gives us the confidence interval. So with that, it will just look like a way. I'm trying to actually bring up a file to show you what I'm trying to say. Yeah, so you should be able to make analysis in such a way that you can say this is a confusion, like this is what happened here. We call it confusion matrix. Is it correlating or not correlating? So you should be able to make those kind of claim that this is what happens here. So if you look here a bit, so you see that here, this one, you see here, what we have here, I'm able to now make this and say this is what happened here. This is the correlation between 2013, 215, 217, 219, and 223. So these are the relationship that take place on these places over time. So I will be able to use that now to now look at this. So also making comparison between them, and that's how I'll be able to say it is in order or not in order. So when you finish that, you should be able to make, or we are going to make that particular kind of we're going to make that particular kind of analysis when we are doing supervised classification. So there we're able to say this is the interval, this is how much I trust this particular thing I did, that it is right or wrong. You get what I'm trying to say?
Yeah.
All right. So yeah, so that's it on this. So we call